HCHO2, not something I memorized, starts with H, weak acid. Since it's a weak acid, I can dissociate it, write out its ice chart, write its Ka. Dissociating the weak acid, I use equilibrium arrows. I take one H off. Everything else stays together. My ice chart, this side is 0 plus X. This side will be minus X. And then I slow down and realize I don't have a value for here. I don't have a molarity of HCHO2. In fact, that's what I'm looking for. I want to find the molarity of HCHO2. What I recommend, just so you can keep going with the process how you're used to it, put something here other than X. X we always use to represent the amount dissociated, the H plus concentration. So I recommend use M or use Y, use some other variable that's going to represent the molarity of HCHO2. Again, when we subtract X from it, since it's a weak acid that barely dissociates, we're still just left with Y. That way I can keep going. I can set up my Ka to be products, X times X, or H, this value times this value, X squared, over reactants. The Ka value I can get from my chart. It will be the Ka value for whatever I dissociated, HCHO2. 1.9 times 10 to the negative 4 equals X squared over Y. I left parentheses there blank because I know if I'm ultimately solving for the Y value, I must have some information that's going to give me my X value. The information I have that I haven't worked with yet is the pH being 1.9. pH being 1.9, I know that 10 to the negative pH will give me my H plus molarity. I also know that X represents my H plus molarity. So that will be my X value that can go in those parentheses, allowing me to solve for Y, which is what I want. 10 to the negative 1.9 is my H plus, which is my X value. 0.0126, that can plug in for X. It doesn't plug in for Y because X represents H plus, and what I just found represents H plus. 0.0126 squared. Solving this for Y, I recommend put over 1 and cross multiply. So 0.0126 squared times 1 is 1.5, sorry, this is all separate, 1.58 times 10 to the negative 4th equals 1.9 times 10 to the negative 4th Y. Divide both sides by the 1.9 times 10 to the negative 4th. And I get a Y of 0.834. Y represents the molarity of my HCHO2. So that is my answer, and I'm done.